And welcome to the Daily Space Weather. Smasho here, coming at you from the Smash News Network, least busted name in news, just bringing you the most comprehensive space weather and daily images of the sun you'll find anywhere in the known universe. This is the last 24 hours from the GOES-R. Two wavelengths here, ionized iron and helium, 195 plus 304 angstroms. We've got some CMEs, coronal mass ejections to cover, also likelihood of solar flares very high, large flares, also a new filament rising down here in the southeast. Let's take a look at that in a little bit more close-up detail. So that's one that's worthy of a name. It is indeed quite a large filament. There's a slightly more zoomed-in view of that. Great absorption feature showing up there, dark, meaning less ionized helium and iron in that area. Northeastern limb, we do have new sunspots in the north and southeastern portion, so expect at least 2, possibly 3 new named sunspot groups today. Otherwise, pretty stable levels of activity here on the closest star. One pretty cool event popping off over here. It did feature quite a significant coronal mass ejection. We'll show you some spectacular imagery of that later in the video. Here's the southwestern limb. And again, the most likely place, like we said yesterday, the most likely place to see large flares is on the western limb, as we've got a number of large and magnetically complex sunspot groups setting over there. Here's yesterday plus today in SDO intensity gram. Again, that is a lot of sunspots, so the likelihood to see a major flare, I think the likelihood to see an M-class flare over in this area is about 99%, and the likelihood to see an X-class flare is about 67%. So those sunspots are quite large and quite magnetically complex, as you'll see on the colorized magnetogram imagery. And just to reiterate, we do have at least 2 new named sunspot groups. I think it's actually going to be 3 new groups just rising, maybe even as many as 4 new groups rising over the eastern limb there. We'll take a look at some high-res imagery toward the end of the video. Now, if you like the content, if you would like to see it continue to exist, remain publicly visible and free for all to view, consider becoming a member of the Smash Team. Thanks to our spaced-out Smash Team members, and good morning, Tin Man 1057. Smashomash.com/Smash Team is the official subscription services site for the channel, and we are still on Patreon. Hit us up on Discord. If you want to send an instant message, you can find the links on the homepage and below the video in the description. Smashomash.com/Smash Team. Join at the gold or silver level especially. There's also a bronze level. We do send out disaster alerts. You can also find links to the Hemp Lucid products, so check those out. Maybe improve your health with some Hemp Lucid solutions to problems like stress, problems with sleep, or perhaps just general inflammation. Shop by solution. Don't forget to enter the promo code SMASHOMASH to save some dough on your checkout. And also Smashomash.com if you want to help the channel and you're unable or unwilling to open your cobweb-encrusted wallet. Why not help us out with clicks? Go visit us on social media. Press share. Press the comment button. Press the dislike button if you don't like what I say about things like the electric universe nonsense. If you think you're going to hurt our feelings by putting up a mean comment, please, by all means, have at it. Just keep in mind that we are free speech purists, and we will not censor your comments. We don't ban, block, or mute anybody on the channel, but we might berate them if they say something stupid, because remember, folks, ignorance is the root of all knowledge, and while there's nothing wrong with ignorance, stupidity could pose an issue. You may have noticed some bad decisions on planet Earth for the past 3 years. Today's featured product, by the way, is Do Not Pole Vault the Caldera. So while things can certainly get worse, our finest days lie ahead. So whatever you do, don't pole vault the caldera. To quote Churchill, If you're going through hell, keep going. There is a light at the end of the tunnel. And thanks to everybody who's picked up merch over the many years, the Do Not Pole Vault the Caldera products are our best seller. Great bright imagery there. Colorful public service message there from Smash staff and I at Massive Personal Risk and Expense, which brings us to conveniently our next segment, where we will briefly cover volcanoes. So if you know any pilots out there, perhaps recommend them to our channel, as we can make their lives a little safer with things like cosmic ray forecasts. Anyway, Shivaluch is exploding and producing a 15,000-foot ash plume over the Kamchatka Peninsula. Please do not pole vault the caldera. Subanose Jima also erupting flight level 060. Flight level 060 also at Luatolo. That's a 6,000-foot ash plume. 5,000-foot ash plume coming out of the daughter of Krakatoa. Krakatau, one of the great names of any volcano. And what do we got? We got a strong glow illuminating the broad part of the edifice. So there could be additional activity happening there at Krakatau. Semeru also exploding on the Isle of East Java, Indonesia, producing a 14,000-foot plume of volcanic ash. Flight level 140. Flight level unknown over Popocatépetl, although it's likely still erupting. One of the most active volcanoes in the world, Popocatépetl in central Mexico. Sangay in Ecuador exploding, flight level 210. Cotopaxi exploding, flight level 210. And not sure about Sabancaya. And let's move to global seismicity. So it is a bit of a 7 magnitude earthquake drought here. We've seen 2 6+ magnitude quakes over the past 24 hours. The first one happened near the Solomon Islands there. That was a 6.1 at an estimated depth of 86 kilometers. That came in at 22:19 Universal Time yesterday. And more recently, just this morning, there was a 6.0 off the coast of Japan. There is a location of that south of Sapporo. That was a 34-kilometer depth quake at 9:18 Universal Time this morning. And let's run up the list here. We'll cite quakes over a 5 magnitude. So again, there was a 6.1 at the Solomon Islands, northeast of Australia. Indonesia had a 5.0. That was at 4:19 this morning. Philippines had a 5.3 at 5:51 this morning. And then Japan had that 6.0 at 9:18 this morning. And let's get back to space. Welcome to space. If you think it's fake, if you think the sun is fake, please buy a cheap telescope and put a solar filter on it and go look. We're not making this stuff up. That's actually 284 plus 171 angstroms from the GOES-R. We've also got the 195 angstroms wavelength, which, by the way, the GOES-R 195 angstroms wavelength is super spectacular. I mean, look at how wide the field of view is there. And also it shows great details all the way down toward the chromosphere and some extended corona also. So that's a fantastic wavelength. Highly recommend the 195 angstroms. It is another species of ionized iron from the GOES-R. We do have a coronal hole rotating in. I think the coronal hole high-speed stream is going to arrive a little bit earlier than a lot of people are expecting. Here's 304 angstroms by itself. Just ionized helium. And the 10.7 centimeter radio flux is now down to 158 solar flux units. There is the 1-year graph. The black line is the radio flux, and if you're not familiar with it, the radio flux and the sunspot number are directly proportional. So if you head to the Space Weather Enthusiast dashboard and you scroll all the way to the bottom, you will find historic graphs. And we can extend this one a little bit to include the ramp down of solar cycle 23. And there is a great example. You can see how indeed directly proportional the radial flux and the sunspot number are. So the sun's about to break out, folks. The limited amount of activity that we've been seeing recently here is about to come to an end. And we are awaiting additional magnetic field progression. We'll talk about it in a moment. First, a Space Weather Enthusiast dashboard NOAA report on space weather. No forecast there for anything. I'm expecting the coronal hole high-speed stream density portion to arrive by around midday on the 30th. It's going to arrive a little bit earlier than expected there because there is some less defined coronal hole material ahead of that more well-defined portion. So we're expecting the high-density wave to show up and the high-speed portion to show up as early as before March 31st. So that could cause a geomagnetic storm condition. Don't be surprised to see a KP6 as a result of the coronal hole high-speed stream because, well, we've been seeing fireworks with the South Pole current sheet. Next, Earth's magnetic moment for the past 4 hours, and this is jacked up, by the way. I'm going to explain why in a moment. So this is the past 4 hours of Earth's magnetic moment from space modeled by the Space Weather Modeling Framework, and this has probably got some major errors in it because this uptick that you see right here is probably not legit. And let me just explain what I mean by that. The reason I say that is because if you click details down here, there is a link to the Space Weather Modeling Framework, and that'll direct you to other websites that explain to you where this data is derived. So this model is derived from a whole bunch of different features, including one of the most important ones, which is the real-time solar wind. And I'm going to show you why here in a moment. This does not look legit, at least the beginning portion of it. The last about hour of that 4-hour run does look legit. And it's because of missing data on the solar wind. So we'll show you that here in a minute. First, Earth's magnetic moment from the ground. You'll probably see a similar uptick here in the past couple of hours. We do have a slightly elevated solar wind here. Last I checked, it was about 540 kilometers per second. And as you see this run play through here, there you can see that big uptick. And that is a result of missing data on the real-time solar wind. So KP index currently at 1.33. Geomagnetically calm conditions here for an extended period. And I just put up this diagram to show people that the solar wind is measured out at Lagrange point 1. So keep in mind that is not a direct, that's not the Earth's magnetosphere being hit, that's outside the Earth's magnetosphere. And so here's what we're talking about. So the reason it's showing such low levels of magnetohydrodynamic pressure on the geospace magnetosphere movie is because of this void of data right here. So that's, I'm not sure exactly what it does there, if it just keeps the oldest signal and just assumes that's still going on. But that signal was 357 kilometers per second for the solar wind speed and solar wind density of only 0.4 protons per cubic centimeter. That was what the ACE was picking up, or at least what it was reporting. And then the Discover, when they switch to the Discover, you can see it jumps way up here. Solar wind density looking more reasonable and believable at about 6 protons per cubic centimeter. Solar wind speed here, again, still elevated at 528 kilometers per second. So just take those magnetosphere movies with a grain of salt, especially if you have never read about the Space Weather Modeling Framework and seen all the different variables that are used to determine that model. Next, magnetic data here, and we're getting a little bit more of a range with the GOES magnetometers. GOES magnetometers were in a very tight range. Past couple of days, a little bit extra variation there. That's the 7-day graph. We normally show the 3-day. And let's take a look at the heliosphere. So here's the heliospheric current sheet, and Earth is right in the middle of a South Pole current sheet here. Welcome to the South Pole. Yeah, the South Heliospheric Magnetic Pole. North Pole is on the opposite side of the sun here at the moment. South Pole current sheet is large and currently in charge. Next, our line of sight field plot. Here the sun's B field is depicted in blue. Solar polar fields in green for north and red for south. And let's get to perhaps the most important feature of all in a solar cycle. I consider them more important than sunspots. although they are much more recently discovered. Coronal holes weren't discovered until the 1970s. And people were quite amazed. So anyway, that's our line of sight coronal hole plot, and we've got lots of South Pole-oriented coronal holes here. Let's take a look at the view from the SDO 211 angstroms wavelength. So give that a minute to initialize here. And here we go. So there is yesterday plus today in SDO 211 angstroms wavelength. We'll zoom way in to give you a better detail of that well-defined coronal hole there right across the equator. Also more coronal holes rotating in here. Those systems perhaps even connecting, it looks like. So that's super interesting. Watching a little bit of coronal hole growth happening there. And we did watch this one grow about a week ago also. So coronal holes, super important as they give us insight into the solar polar field reversal process, which is perhaps one of the processes that runs the sunspot cycles in the first place. Speaking of sunspots, let's get to those. And there are lots and lots. Again, I think we're going to have at least 3 new named groups, maybe as many as 4 new named groups over here. At least 2 new named groups, 2 to 4 new named groups, I'll say, over here in the east. They'll be starting with number 3265. And again, the likelihood of large flares is getting higher and higher as these sunspot groups approach the western limb. Our regular viewers are well aware that sunspots at the limbs are much more likely to produce large solar flares, at least from the perspective of Earth. And, you know, part of the reason that's so interesting is because of the possibility that solar flares are anisotropic, meaning if a solar flare comes from here and you're viewing it from here, it may show you a different amount of X-ray flux density than if it's viewed here. And that might be different than if it's viewed over here because of the angular emissions of certain types of matter. Anyway, again, likelihood of solar flare is very high. Lots of sunspots, expecting a couple new named groups to be named today in the eastern limb. And let's take a look at the SDO intensity gram once again. That's just today's images, by the way. And those are mostly stable, at least throughout the day today. A little bit of umbral migration happening here, a little bit of differential movement of that plasma there. You can see the leading North Pole umbra there accelerating away from the North Pole, the South Pole trailing umbra. But besides that, not a lot going on. Let's move to energetic particles and solar flares. No spikes in the proton flux. No energetic particles showing up, and we've only had a few minor C-class intensifications over the past few days. We have seen a little bit of an uptick in the X-ray flux, and we can expect a bigger uptick in the X-ray flux once again as those sunspots approach the limb. Even if they don't produce major flares, the X-ray flux will still rise in the coming day or two. So here's the past 24 hours and 131 plus 94 angstroms from the GOES-R. Some of the activity that we saw was in the northwestern limb. You can see that plasma plume happening up there. A very sort of orderly plasma emission happening there. A very large area. All kind of erupting in a uniform fashion like a giant flux tube. That's the area that I'm talking about. That's about 8 Earths in diameter. Pretty impressive. High likelihood of major flares from the southeastern limb as well. Southwestern limb is what I meant. Southwestern limb. And let's take a look at stars. So, before we get to coronagraphs and coronal mass ejections, let's take a moment to orient ourselves. This is where things are located. This is the sky over Lehigh Valley, Pennsylvania. And Mercury and Jupiter very close to each other in the morning sky here. And so if you've got a good view of the sky in the evening, it might be a great time to view Mercury and Jupiter there. Jupiter showing up just south of the ecliptic plane and Mercury just north of the ecliptic plane. Speaking of the ecliptic plane, there's a top view of the ecliptic plane. That's the plane on which the planets orbit, basically the sun's equator. And here's your solar system forecast. As we approach a full moon, that's where things will be on April 4th, on this lonely side of the solar system, devoid of planets entirely. Does that spook you? I know a lot of planets and a few planets spook people, so maybe it's very spooky and scary to be in a part of the solar system that lacks planets, just like it's very spooky and scary to be in a portion of the solar system that has planets. By the way, the planets don't govern solar activity, and magnetic fields don't govern planetary orbits and or planetary axes, and channels that are telling you that are full of baloney. Full of baloney. So here are some coronagraphs. There's yesterday's imagery. There was one quite spectacular CME right there. And it did bleed into today, so it happened right around midnight. There's today's 14 frames. And let's take a look at stereo A's perspective, which is only a few degrees behind the Earth orbitally speaking now. So it's not really helping too much with calculating the trajectory or velocity of coronal mass ejections, only a little bit. It's only a few degrees behind Earth. So that's kind of unfortunate. And that's going to be going on for a long, long time. Not optimal as we approach solar maximum. So getting there towards solar maximum, there are some images of that CME happening, especially out of the northwestern limb. Here are some 24-hour videos. These will show it a little bit better. A very dense core coming out of that CME. Let's look at it a little closer. You can see like multiple bubble layers happening there, and a very dense trailing core there. So that's the kind of CME that if it was Earth-directed, that could cause a major geomagnetic storm like a KP8 type event. And thanks for leaving a comment, General Disturbance. Yeah, you know, the thing about asteroids that a lot of people don't realize is that we don't know where they are. We can't see them. I mean, people with backyard telescopes discover asteroids all the time as a result of occultation, meaning they're looking at a star and then something gets in the way of the star and then they track it using their computerized telescope. And I mean, yeah, asteroids super dangerous. You could be hit by an asteroid right now in the middle of this sentence. There's not going to be any warning. It's kind of the ultimate sniper round because it's going to be showing up at like 60,000 miles per hour. And that's not going to give you ample warning. Look on the bright side. If your car is destroyed by a large iron meteorite, you'll be able to pay for your car and a lot more if you salvage the iron meteorite. Anyway, there's a great image of that core. Also, 195 angstroms there from the GOES-R. Spectacular imagery there. That's a 24-hour video. Soho Lasco C2, C3, and the GOES-R. DAG. That is a good one. Next, looking at filaments. And again, we've got this new, really gigantic filament down here. And that one is probably worthy of a name. I've got ideas. So I'm going to bring up the latest image. And if any of you beat me to naming this on Twitter, then you'll have named that filament. Don't forget to follow the hashtag, #NameThatFilament. So here's the past 24 hours in GOES-R, 171 angstroms. And let's take a look at the last couple of hours from the GOES-16. Yes, especially iron meteorites. If you want to make a Damascus knife and you make it out of an iron meteorite, you have now made a shockingly expensive Damascus knife. All right, so there's what's going on the past couple of hours from the GOES 16 SUVi, which brings us to our bonus features segment. We do have a bit of plasma instability happening around these areas here. So the stage is definitely set for major solar flares and significant coronal mass ejections. They could be earthly directed. We'll keep you posted. That's part of the purpose of the channel. And here come bonus features. First is our satellite charging hazards. We don't have any. Things are clear out there for satellites. No surface or internal charging hazards at the moment. GOES electron flux here still pretty flat, but just hanging out there right around the Space Weather Prediction Center alert threshold level. And it looks like it might be leveling off here. Let us know in the comments what you think. Here is NOAA's forecast. NOAA is expecting a precipitous dip. I think it's going to be flat today. And within 2 days, I do expect it to drop. But anyway, that's the forecast model, the green boxes. And there's the one-year graph to put the relativistic electrons in context. Those are measured at the F layer of the ionosphere, which is what we'll show next. Here's the vibrational frequency of one thin slice. The upper thermosphere, the bridge between Earth and space at about 300 kilometers, the F layer of the ionosphere's vibrational frequency. So that's megahertz, millions of vibrations per second. Certainly some major low-frequency anomalies happening here around West Africa and the central Atlantic Ocean. You may not be familiar with looking at this, but that's okay. We'll show the anomalygram. So we devote 2 frames a day to the ionosphere imagery. Here's the anomalygram. That's anomaly in megahertz from a 30-day median, and it does show 10 times as much resolution. It's showing down to 1/10 of a megahertz as far as anomaly. So some significant anomalies right here around the African Rift Zone for sure. Right around there between Madagascar and Somalia, I'll say. Of course, you're always going to see anomalies around the South Atlantic anomaly, which is located right about here over the South American continent. That is the weakest point of Earth's magnetosphere, and then there's another one over South Africa, which is like over here around the equatorial West African coast. So that's your ionosphere imagery for the day. Let's bring up the latest image. There's 11:30 Universal Time ionogram showing certainly some high-frequency anomalies there, and there is the 11:30 Universal Time anomalygram. You can see a huge puffed up area there in the southern Atlantic Ocean and Southern Ocean. We'll also show the total electron content. That's the free electrons between your GPS satellite and your handset, which is located in the inner portion of the outer Van Allen belt, seen here. And if you're not familiar with this image, feel free to pause the video on this frame. If you're not familiar with the distances to things like the SDO or perhaps the International Space Station. So here is the total electron content. That's the free electrons in the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model, or CTIPE. Things are pretty orderly here, as we typically do see with high electron contents. However, there are some anomalies to note. We're only going to show North America and the U.S., so there is the anomalygram. That's anomaly from the 10-day average. I would note that we did forecast the possibility of a large earthquake for western Mexico, as we're trying to integrate more and more information into the predictive value of the videos. We did see some persistent anomalies a few days ago, and we're running out of the alert window here. So if we don't see a significant quake like 6+ magnitude in western Mexico by tomorrow, then we'll have to go back to the drawing board there. I believe that is the first time we've used that data to attempt to predict an earthquake, forecast an earthquake, whatever you want to say. And here are our latest images. So again, we do have, there's at least two sunspot groups right there, as there is an umbra, and there is another umbra. Down here in the southeast, at least one new sunspot group. So we're at 3 sunspot groups likely to get names. That might be an umbra also. That does not look legit though. So it looks like we've got at least 3 new sunspot groups to get names today. Most likely places to see large flares are in this tight region right over here. That is the most likely place to see a large X-ray flare, and as those get closer and closer to the limb, they become more and more likely to produce a large output of X-ray photons. That brings us to our meteorology segment. Before we get there, a quick reminder to join us over on Twitter. Don't forget to follow the hashtag #NameThatFilament. If you want to name filaments after living people, also follow the hashtag SpaceWeather and SpaceWX. That filament's getting a name, so you've all missed out. We're naming that filament Shaq. So that's that one right there. That new filament in the southeast, now named for retired basketball star, one of the top scorers of all time, Shaquille O'Neal, as that is another huge filament, and he is a huge specimen. So follow us over on Twitter. And most importantly, don't forget to press like, subscribe, share, etc. on YouTube. Thanks to everybody who has. If you want to know what goes into the making of these videos, we did a live stream just on Sunday. So if you want to check that out, we painstakingly went through the whole process live on YouTube to explain how the videos are made, as we want you to be able to forecast your weather, whether it's in space or on the ground. So transitioning here from space to the ground, we're looking at Earth's likely auroral ovals. So one of the great features of nullschool.net is that it will actually show you where you're most likely to see the aurora. So not too far from New Zealand and Tasmania there. And we've got some likely aurora in places like Western Canada, Alaska, and Siberia. So there's your auroral map. If you want to look at that yourself on nullschool.net, just click on space, as one of the layers is space. Although that's the only choice, is the aurora. Anyway, let's move to the surface winds of the eastern world. Shout out to our viewers from all around the planet, and thanks everybody for leaving so many comments. We greatly appreciate your commentary. There is your jet stream scenario for this side of the planet. Pretty chaotic jet stream there in the southern hemisphere. And a tripled up jet over East Asia. Here are the jet streams of the West, the Americas. There we go. That's a pretty good view. Concentrated jet stream over the eastern U.S., and it's cold. The forecast is cold for Pennsylvania for today. We're only expecting it to be in the 40s. There is the surface wind scenario. We've got a low off both the east and the west coast. Much stronger one there off the coast of Washington than this one in between the Azores and Greenland. That's a weaker low. You can see the difference in wind speeds. Here is the surface wind scenario for Europe, Africa, and the Middle East. And there is the jet stream situation on this side of the Earth station. Next, looking at clouds and fog. We show it daily on the channel to bring people closer and closer to their local weather. Yeah. We zoom in all the way from the sun to Earth. Sometimes we even talk about cosmology, but for the most part, space weather down to Earth weather, zoomed in all the way to the U.S. lower 48 scale. So there's clouds and fog over the lower 48. Here's your weather.gov map. We'll scroll down and briefly show you the key. We don't spend a lot of time talking about weather.gov, but if your location is lit up, click your location on weather.gov. The radar map that we use later in the video is radar.weather.gov. I even have it saved as a favorite on my smartphone, my quote, smartphone, end quote, which is about as smart as an inanimate object. Next, our pressure and precipitation forecast for the next 72 hours. That is the GFS model, and guess what? Additional snow and other precipitation coming to California, and some major ice expected to strike Minnesota, Wisconsin, and Michigan. Here's your 72-hour GFS precipitation. That's accumulated precipitation in inches. And that's a lot of precipitation for California. California. And here is our accumulated positive snow depth change based on the same model, the GFS 72. And significant portions of California there expecting 2 more feet of snow. By the way, if you're not aware, expect an epic melt season this year, because this is the seventh. This is your 7th consecutive winter of record snowfall in the Northern Hemisphere. So you can expect extreme melt seasons. Now, of course, the fact that the previous 6 winters have helped to soften things up, there is a lot of snow water equivalent in the mountains. So it's going to be a melt season, possibly the biggest one yet. I mean, the snow water equivalent is just ridiculous. Go look at globalcryospherewatch.org if you don't believe me. That's your 72-hour accumulated positive snow depth change forecast. And for those people in the mid-Atlantic states, quick reminder, folks, we're located right about here in Lehigh Valley, Pennsylvania, right about there. And this area right here is certainly capable of receiving major snowstorms even into April. So don't be surprised if we see more accumulated snow in the mid-Atlantic region of the country. That's your 72-hour GFS positive accumulated snow depth change in inches forecast. And let's continue on as we've got some severe weather here, once again showing up around the Gulf states. So this is our visible satellite. Fantastic imagery there from windy.com as it ties together different data points there to provide the best visible imagery that you can get. You can see the sun rising there over the cloud tops over the western Atlantic. One of the many features of windy.com, which has a free mobile app, if you weren't aware. Next, our lightning mapper. And by the way, we've switched this. This is a little bit different than what we've been showing before. We switched this to the group flash count density. That's basically the area that will be visible. You'd see visible lightning flashes from those locations. You can see quite a train of lightning there, stretching all the way from southern Texas way out to Bermuda. And let's check out the active cells, as we had some when we did show prep. Indeed, southern Georgia there, southern Mississippi, southern Alabama, Louisiana. All seeing some active cells. What do we got? There is some thunder rolling into Macomb. And it looks like that system's moving to the east-northeast. Of course, you can track lightning strikes. That will help you get an idea of the storm track if your Doppler is not making it clear. So quite a bit of lightning happening here around the Gulf states. Some significant thunderstorm activity there. Next, we'll look at the U.S. Doppler radar. There's the full 50 states of AUSA, former nation, now Banana Republic. Here are the lower 48. We'll briefly take a look at this situation here. Strong but isolated cells there, so no really huge cells, at least not yet. And let's take a look at clouds and fog. Rapid cloud nucleation happening there around Louisiana especially, it looks like. And there is water vapor. And when you see water vapor spontaneously appearing right here, that means high-speed convective processes there. Water evaporating out of the ocean and ending up in the air. That's a huge convective zone right there. Basically, it's a low pressure forming right before your very eyes. Anyway, here's your recap U.S. Doppler radar from radar.weather.gov. Clouds and fog on the NASA GOES Interactive Weather Satellite Suite. Shortwave radiation, 3.9 nanometers. And don't forget the 6.19 nanometers, otherwise known as water vapor. Don't forget to press like, subscribe, share, etc. We'll see you soon at the Smash News Network, Least Busted Name in News. Thanks again for tuning in, and may that solar wind be at your back.